Good morning everyone. In this video we will be talking about the displacement, velocity, acceleration, time period and frequency of simple harmonic motion. Any of it can come for your exam also, okay, carrying 2 marks or 3 marks maximum, okay. And the formulas, the final equations will also be important for solving, will also be useful for solving numerical questions. Now firstly, let's talk about the displacement. Now consider a particle revolving in circular motion in anti-clockwise direction, okay. Particle moving in an anti-clockwise direction in circular motion. Now let the center of the circle be O and the radius of the circle be R, okay, small letter R. Now at time t equal to 0, okay, at time t equal to 0, let the particle be at the point A over here, okay, let the particle be at the point A. And after time t, okay, after time is passing at t, then let the particle be at the point P, okay. Now so it makes an angle, omega t, okay, with the radius. And now we will draw perpendicular along the y-axis from the point P, okay, here Pn is the perpendicular, and let the distance On be y. Now we will take triangle ONP, okay, ONP, we will take triangle ONP. Since this is omega t, here it will also be omega t, okay. So since it is alternate angles. Now if we take triangle ONP, if we consider this angle and omega t, this angle, then what will be the perpendicular? The perpendicular will be ON, right? This will be the perpendicular and this will be OP. The R will be, the radius will be the hypotenuse, right? If we consider this angle from triangle ONP. So in right triangle ONP, sine omega t, if we take sine omega t, what is sine? Sine is perpendicular by hypotenuse, right? Some people have. So what is the perpendicular? The perpendicular is y and the hypotenuse is r. So if we cross multiply it again, we will have y equal to r sine omega t, okay. So let's give this equation number 1, y equal to r sine omega t. Here r is the radius of the circle, and this value of r is what we call amplitude, displacement amplitude, or simply amplitude, okay. This r is what we call the amplitude. Now the amplitude of the simple harmonic motion is defined as the maximum displacement on either side of the mean position, okay. So what does that mean? This amplitude is the maximum displacement, so the value of r will be the maximum distance it can travel in a circular motion, right? So consider a pendulum moving on either side. So since if the pendulum can reach up to this point and up to this point, then this is the mean position, okay. So that from the mean position to the maximum distance it can travel, that is what we call the amplitude. So in circular motion also, from if we take it from the center, the value of r, the radius, will be the maximum distance that it can travel, right, in circular motion. So this r is called the amplitude. Now omega, since omega is equal to 2 pi by t, okay, the value of omega is 2 pi by t. So if we put this in equation 1, then what will we have for y? We will have r sine 2 pi by t, right? If we substitute this in equation, the value of omega in equation 1. So let's give this equation number 2. So equation 1 and 2 gives the displacement. Y is the displacement, okay. Y is the displacement, this y, the distance between the initial and the final position, okay. So the perpendicular distance between the initial and the final position is called displacement. So these two equations can both be used to calculate the value of displacement depending upon the condition, okay, depending upon the situation. So that is about displacement. Now let's talk about velocity. This is about displacement. Now let's talk about velocity. Now consider, we'll draw another figure. Consider a particle again moving in anti-clockwise direction in circular motion. Okay, I'm not very good in drawing. Consider another particle moving in circular motion, and it can let the particle again at the point P at time t equal to 0, let it be at point A, and at time t equal to t, just like the same, we'll use the same introduction, okay. Let the particle be at the point P, and let the angle made by it be omega t, and let the radius of the circular motion be r. Now we are talking about velocity, right? So the particle, let us assume that it is moving linearly, okay, means it is moving straight. So if you're going to draw linear line, straight line from this point P, it means that we are drawing tangent, right? So it is like we are drawing a tangent. So this can be resolved, this direction, this tangential direction can be resolved into two components, okay. So we can solve it along this direction, and we can solve it along this direction, okay. Velocity hi hian ngatinge hemi direction pani hian kan di resolve kherna chan chu velocity ni mewa atlan chak zong average velocity kha atlan chak zong a velocity average lai taka kha khami kha hriat kan du sia sar kalina kal box sia sar kala thil kwala chuanin ei velocity hi atlan chak tak thelo hitro kong kwala te po kan speed kan down zela ngai kha khami bank road sa te po kan zir to ta chuman chon circular motion in a kal box hi ama se average value kan du box hi wangin asar kalang zonga direction anga cho hi chuanin answer dik tak kha chuak hara chuan angil turangin kan hisapa kalngil turangin kan hisapa chu ta po direction che ni in hemi perpendicular direction component pan in kan la resolve le te ni chu. So this is perpendicular to the y-axis, okay, this part. So let the tangential direction, we will give the velocity, we will give it capital letter V, and this perpendicular direction will keep it small letter v, okay, and in this direction we will put it v dash, okay, small letter v dash. Now we will resolve the particle along y-axis, okay. So this is the v dash is the velocity of the particle along x-axis, and v is the velocity of the particle along y-axis, okay. So we will resolve the particle along, we will take the particle along the y-axis, okay. So this is given by, if we resolve the particle, the velocity of the particle along the y-axis, it is given by v, right? So v is equal to v cos omega t, okay. The angle is also here, this angle is equal to this angle omega t. The angle between v and v, capital V and v, is also omega t. If we are going to resolve it using this v dash, okay, if we are going to resolve it using v dash, we will get it like v sine omega t, okay. But it is not necessary to solve it using the two equations, okay. We will only use this y-axis, okay, v equals to v cos omega t. Now before that, what is linear acceleration? What is linear velocity? Linear velocity, we studied in first term, linear velocity is r omega, okay. This equation, if you look back at your first term notes, you will see linear velocity is equal to r omega. So if we use this r omega in this equation, we will have v equals to r omega cos omega t, okay. So we'll put this equation 3. Now again, omega is equal to 2 pi by t, right? This is the value for omega. So if we again use this 2 pi by t for the in place of omega in equation 3, then we will get r, we will not, I will write 2 pi by t first, okay, 2 pi by t, then r, then cos, here also omega, I will use 2 pi by t, 2 pi by t, t, okay, here small letter t is still here. So this, we'll put this equation 4. So these two equations, equation 3 and 4, give the velocity of simple harmonic motion at any time t, okay, at any time t. These two equations, either one of them can be used to solve the velocity of simple harmonic motion. Now again, like if you look at equation 3, let me rewrite this equation 3 again, v equals to r omega cos omega t, okay. So again, if we rewrite r omega cos omega t, now we will just solve it, okay. This will be equal to, there is no particular equation, okay, we will just rearrange it. This will be equal to r square cos square omega t, okay. How tingin equal dan? How is it equal? If we remove the root, then this square will be gone, right? If then we are getting this again, it is the same thing. Ay ang renga mase answer sidanga kandu wangin, since we want in the answer, since we want the equation in another way, we just solve it however we like, okay. There is no particular formula, it's equal, that is all, okay. If we remove the root, square will be gone, so it is still the same with this. Now you may have studied the formula 1 minus sine square theta is equal to cos square theta, okay. This also you have already studied in high school. So in place of this cos square omega t, I will apply 1 minus sine square theta formula, okay. So it will be 1 minus sine square omega t, okay. Now now again, this is equal to omega root over, I will multiply it with r square, okay. R square into 1 is r square into sine square omega t is r square sine square omega t, okay. Then if you look at equation 1, r sine omega t, what is r sine omega t is equal to y, right? If we look at equation 1 from displacement, y is equal to r sine omega t. This is what we have in equation 1. Let me just rewrite it. So what will be v? What will, if we, this is still v, right? This is still v. So v will be equal to omega root over r square. So what is this? R sine omega t is this one, right? So since it is square, r sine omega t is equal to y, and since it is square, we will just put as y square, okay. So it is still the same. So, or finally, if we put the value of omega, it will be 2 pi by t root over r square minus y square, okay. So let's give this equation 5, let's give this equation 6. So either equation 5 or 6 gives the, it can also give the velocity of simple harmonic motion, okay, depending upon the questions, the data given by the question, the numerical question, we can apply any one of these equations to solve the velocity, okay. Now we'll go to the next topic, which is acceleration. Now we will take centripetal acceleration, okay. So what is centripetal acceleration? This also we have studied in first term. Centripetal acceleration is inward acceleration, okay, when the object is moving, not like this, okay. It is not moving outward, it will move inward, okay, this time for acceleration. Now consider a particle again revolving, again moving in a circular motion in an anti-clockwise direction, and let the angular velocity be omega, okay. This is y-axis and this is x-axis, and let the angular velocity be omega, and let the center of the reference point be O, and let the radius again be r. Now the centripetal acceleration is given by, how do we represent centripetal acceleration? Is given, let us just use capital letter A, okay. this is angular velocity. Centripetal acceleration is equal to r omega square. Okay, this we even studied the derivation in first term if you look back at your notes. So this is the definition of centripetal acceleration, r omega square, where r is the radius of the circular path, omega is the angular velocity. Now the acceleration, like I said, at this point P, okay, the object is, let us consider at time t. Here it is at point A, at time is 0, and at time t the point is at P, and the angle made by the object while it is at point P, again let it be omega t, and the acceleration can be resolved into two components again. Okay, but this time, since it is centripetal acceleration, which is inward acceleration, it will come inside. Okay, so the arrow will point thisward at this side. So the x-axis and the y-axis, it can be resolved into two axes, into two components, x-axis and y-axis. So here it is along the x-axis, and since it is inward, okay, since it is inward, again this will be along the y-axis. So here also this will be omega t, right, since it is alternate angles. Now if we resolve, again we will use y-axis. Okay, we will resolve the particle along the y-axis. Okay, so let this be, right here this acceleration, right, so let us put it a, and here let us put it a dash. Okay, the acceleration along the y-axis, parallel to the y-axis, let it be a, and the acceleration parallel to the x-axis, let it be a dash. So if we resolve the particle along the y-axis, then the acceleration is given by minus a sine omega t. Okay, and why do we have my negative sign? Since it only represent the direction. Okay, minus sign means that does not mean that it will be less than 0. Okay, my here negative sign only represent the direction, since it is inward direction. Okay, even if we didn't put negative sign, the answer will still be the same. Okay, it does not mean that it is less than 0. So what is a? Capital A is r omega square, right? So it will be minus r omega square sine omega t. We are putting r omega square in place of a. Now again, what do we have from equation 1? In the beginning, y equals to r sine omega t, right? Y equals to r sine omega t. Since we have y equals to r sine omega t, so r sine omega t, okay, this part will be equal to y, right? So a will be equals to minus y omega square. Okay, so this equation can be used to calculate the acceleration of a particle having simple harmonic motion. Okay, and this equation is also used for your numerical assignment question number 2. Okay, we use this formula, minus omega y omega square. Omega, remember that it is 2 pi by t. Okay, and oh sorry, not y is not the one which is having negative. Okay, the omega is the one which is having negative, so minus omega square y actually. Okay, so minus omega square y, this is the formula which we can use here. Since omega is square, then minus omega minus again will change to positive. Okay, just as I said before, minus simply represent the direction. Okay, it does not affect the value of acceleration. Okay, it only means the direction. So this is the equation which can be used to calculate the acceleration of a particle moving in circular motion having simple harmonic motion. Now we'll go to the fourth, time period. Okay, then finally frequency. These two are not long. Okay, time period. So the time period of a particle executing simple harmonic motion. The time period, how do we define time period? The time period of a particle is defined as the time taken to complete one rotation, okay, or one vibration, or that is simply time period. So for the case of the earth moving around the sun, 365 days is the time period, right? It takes 365 days to come to have one rotation or one vibration, right? So that's just the definition of time period. Now we will use the previous answer, a equals to omega square y. This time I will not put negative, okay? We have a equals to omega square y. So, or what is omega? If we want to solve the value of omega, it will be omega square will be a by y, right? Which means that omega is equal to root a by y. Now, what is omega again? Omega is 2 pi by t, right? 2 pi by t is equal to root a by y. Now if I cross multiply it, if we separate this root a by y, we can also write it like root a by root y, right? It is still the same. So if I cross multiply it, root a t, okay, root a into t is equal to 2 pi into root y. Or what is t? What will be t? T will be equals to 2 pi. The root a will go downside, so it will be root y by a, right? So this is the value which can be used to calculate the time period, 2 pi root y by a, where y is the a is the acceleration and y is the, what do we say, what was y? Y is displacement, okay? Y is the displacement. And if we know these values, then we can calculate the value of t. Or we can still write it as root y by a. If I want a and on top, then I have to write it like 1 by a by y, right? It is still the same. So if we are going to define it in words, then t is equal to 2 pi root 1 by, what is a? Acceleration, right? Acceleration by, right, per unit. What is y? Displacement. Okay, so this is not that important, okay? If you know this part, or either this part or this part only, is also enough to solve numerical questions. Now, since here, if we look at our previous step, omega is equal to root a by y. Or since omega is constant, okay, since omega is a constant, it means that here, it means that the simple harmonic motion, okay, the simple harmonic motion is a constant quantity, okay? That is, what does that mean? It means that the time period of a simple harmonic motion, is not depending upon the amplitude, okay? So here also we are having acceleration and displacement. There is no amplitude, right? So time period is not depending upon amplitude, since omega is a constant quantity. So root a by y will be constant. Now finally we will talk about frequency. Frequency we represent it by mu, and frequency is simply the reverse of time period, okay, 1 by t. So what is mu? What is time? Time is 2 pi root y by a, right? So since frequency is the reverse of this formula 1 by t, then we will just reverse this one. So it will be 1 by 2 pi root a by y, okay? This will be the formula to calculate the frequency, okay? Nothing long to study from frequency. And this part, if those who are looking at old syllabus, okay, those who are looking at old syllabus, your textbook make a mistake, okay? This part in textbook ka old syllabus law zir ve law en ve deuh tan kha chon helai bor hi ka chaw dan lo hian an choka in textbook a khan an chu sual an ti suala o hi rin jok tur ro heta ka je dan hi